Hello, welcome. This is the Freedom Research Podcast, and my name is Hannes Sarv. My guest today is a scientist from Australia, a researcher, a biologist, Jennifer Marohasy. Sometimes I understand Jennifer also calls herself an old-style feminist. Is it correct, Jennifer? Hello.
Yes, lovely to meet you. I guess, yes, I do call myself an old-style feminist in so much as I've been in the workplace now, I guess, for 40 years, and 40 years ago it wasn't always so easy. And if you go back a little bit before then in Australia, when women got married, they were meant to actually give up their jobs. They weren't meant to continue working. But I think things have almost gone in the opposite direction now, where women in the West are to some extent privileged in the workplace. But I'm not an expert on any of that.
Yeah, General. I understand that, by reading your webpage or a blog, that you are really, I would call you a libertarian thinker, and freedoms and personal freedoms, individual freedoms, really are meaningful to you. So, am I right?
That's correct. Certainly every time I do one of those tests, I come out as an extreme libertarian, which surprises me a little bit. But yes, I guess that's how I come out on the test. And certainly I see myself as an empiricist. So what's most important to me is the evidence. And you need an amount of freedom to be able to get to the evidence.
Yeah, Jennifer has also made some really meaningful contributions related to climate change or global warming research, whatever you call it. One can say that she has a bit of a contrarian view on climate change when compared to, let's say, mainstream scientists, mainstream climate scientists. But firstly, Jennifer, your background is really, I would say, inspiring. As a biologist, you have worked not only in Australia, but in many places in the world. So please talk us through that.
So I graduated from university 40 years ago with a botany and entomology double major. And I actually went to work as a field biologist in Madagascar. That was a long time ago. And I think graduating at that time and in entomology, you got a very good statistical background, which has been useful in the last 10 years. I've been publishing in climate science journals. But if we go back 40 years ago, I was in Madagascar soon after I graduated, running field stations and collecting insects and rearing insects. And at that field station, we had weather stations. I was recording temperature data and always thinking about, I guess, temperature as it affects the distribution and abundance of the insect species that I was interested in at that time. I then actually moved into environmental management and worked for the Queensland sugar industry for a period of time. And in that role, water was a big issue, especially for the farmers who were irrigators. And for a period of time, we were continually being told that that the drought was caused by climate change and that, it had never been so dry. And yet when I looked at the records, because I've always loved climate records, any sort of data, and the more of it, the better, I could see that really we were just in a dry cycle that was likely to break with flooding rains, as it did. And then 10 years later, I was actually working on some Great Barrier Reef and related issues, and I could see that the city where I'd gone to boarding school, they had built, because it's a city that used to flood a lot, they built this Wivenhoe Dam after the 1974 floods on the basis that the city should never flood again because the the dam was for flood mitigation. Yet going into this what appeared to me to likely be a very wet summer, they kept the dam full of water, and we had flooding rains and the city flooded again. And it was at that point that I went, I'm going to try forecasting, seasonal forecasting. And I was one of the very first to actually publish in the area. This is going back more than a dozen years now, publish in the area of rainfall forecasting using artificial neural networks, using big data sets. So not using general circulation models, but using AI. So, and interestingly, that work was picked up by the Chinese, published in Chinese Academy of Science journals, and picked up by the, close to us we have the Indonesian Bureau of Meteorology. They got me to go up there after I had a few publications in some good journals to show them how you can use AI and big data sets for seasonal rainfall forecasting.
So I understand your interest in climate change topics developed from your own field of experience, your own work.
So I guess over a period of time, you know, like I have an interest, I've always had an interest in the natural environment. That's why I became a biologist. My father was a farmer. I grew up in farms. He was always interested in lunar cycles. And of course, farmers are always trying to work out how the next season's going to be. So from a very young age, my father was always pointing to the sky, where the moon was, you know, how that was likely to affect the rainfall for the day, for the month, and also for the season. And I guess, so one of my colleagues, this is going back a dozen years now, he was using AI for share market trading, forecasting. And I said to him, can we use that same software, but I want to put an array together. I asked him to show me how you put the data together to feed in to the neural network. And then let's see if we can generate some forecasts. And after we did that, we actually went to the Australian Bureau of Meteorology and said, these are our forecasts. We think that you're outputting your data like this before you show it to the public. You sort of confuse how it comes out. But let's get just your output and our output and compare it and see which is the most reliable, which is the most accurate. And they didn't argue with the fact that our forecasts were actually more accurate for particular locations, but they wouldn't move to our method of forecasting, though they're probably going to have to. They're just 10 years behind and a bit. They didn't want to move to that because they said the climate's now on a new trajectory and you're using historic data, you're using cycles to forecast, but they're not going to keep working. The historical data won't keep working for you because the climate's on a new trajectory.
Okay.
And I said, well, for the time that it works, let's try using our method. I was very keen to work with them because to commercialize our method was going to be very difficult. But they didn't, and they still don't want to work with me. And then through that work, I could see how much they were changing the temperature record. And I came to understand how the idea that we have global boiling, I think they're calling it now, is not actually reflected in the raw temperature data for any location in Australia, or I've had a lot of access to Indonesian temperature data, Chinese temperature data, but also I can see how the data is being collected and collated in the States. I'm not sure about Estonia, but in the UK, there's all this homogenization, adjusting of the data to generate this linear trend of increasing temperatures, when if you actually look at the original data for locations, even so we've got very long temperature records for places in northwest Greenland. When you're in Australia, that seems probably fairly close to Estonia, but maybe I've looked at the temperature record for a place called Ubernik, I think it's in northwest Greenland, and you can see how it cycles and then how they change it before they integrate it into these models that suggest that temperatures are increasing in a linear fashion when they're actually not.
So would it be fair to say that they're cooking the temperatures? or not?
They're definitely cooking the books. The interesting thing is that it's going to be a real problem for the West, because we have this, as I said, I've worked a lot with the Indonesian Bureau of Meteorology, BMKG, and showed them how to do the neural network forecasting. And they can't understand this obsession that the West has, places like Australia has, with carbon dioxide. They just don't understand it. And they couldn't for a while. One of the first things they wanted me to do on contract working for them was to show them how they could get a temperature record that increased. And I showed them how the Australian temperature record, it actually shows cooling and then it shows warming. That's the instrumental record for the last 100 plus years. And it's the same for the Indonesian record, because Northern Australia and southern part of Indonesia is the same. The temperature records show the same thing. But what the Australian Bureau does, so that it has a fashionable record, is it drops down the temperatures from the early part of the record to get this linear increase. But that's going to be a problem as we move to AI for forecasting, seasonal forecasting, daily forecasting as well. The West is not going, our weather bureaus are not going to be giving us reliable weather forecasts, because we've so mucked up our historical data. And this has all sorts of implications. If, for example, Australia goes to war with Indonesia, a weather forecast is so important. We know that historically, through the history of even the Second World War, how important it was that the Allies landed in Normandy when there was that break in the weather, and they knew that there was going to be a break in the weather because the meteorologist at that time, he was looking at lunar cycles. He was looking at lunar cycles, and he was looking at accurate immediate data and also historic data. And the West can't do that anymore. We have terrible weather forecasting here in Australia, because they're more interested in the idea of a climate catastrophe than in providing reliable short-term and medium-term and long-term forecasts. It's a big problem, and it's unique to the West.
So basically what you're saying is that we don't have such a climate crisis that is being propagated all around, or do we have a problem with climate? What would you say?
So there's cycles. There's daily cycles. If you've ever recorded weather over any period of time, it's always coldest first thing in the morning before the sun comes up. And there's a diurnal cycle because of the rotation of the Earth that affects daily temperature. And we have annual seasonal cycles, of course, because of the Earth's revolution around the sun. And then we have these 18.6-year lunar cycles, and then we have these 60-year cycles that relate to ocean circulation and overturning. And at the moment, we actually have a little bit of an alignment between the 18.6-year lunar declination cycle and the ocean overturning cycle. So we're probably coming to the end of a 60-year period of warming. And if you actually look at the data coming out of NOAA and places like that, you look at the satellite data for the whole Earth, you can see that there's a lot of the oceans in the equatorial Pacific are very warm at the moment. There's a patch of ocean there that is releasing a lot of warmth. That's as latent heat. It's warming the atmosphere, and it's moving to the poles. So we actually have at the moment, it's the warmest it's getting to the warmest it's been for 60 years. But if we go back 120 years, it was this warm. If you go back 1,000 years, it was probably a little bit warmer. If you go back 400,000 years, you can see the ice ages every 100,000 years. So there's cycles within cycles within cycles affected by different natural phenomenon. The idea that we have a catastrophe as a result of carbon dioxide, well, I can explain the problems with that theory from a few different perspectives, if you'd like me to do that.
Yeah, of course, because this is the only carbon dioxide is basically a demonic gas in today's world. It is something from the heart of hell. So please do explain. Is it or what is the what does carbon dioxide even do? What's its contribution to our ecosystem, so to say?
So the idea, this theory that the West is very enamored with, and that's driving so many of these international conventions, it really, I actually can trace it back. Well, the theory came about going back to 1896. It was written up as a theory, and it really sat there and didn't go anywhere until the 1980s, and Margaret Thatcher was having all the problems with the coal miners, and she actually, her first degree was in chemistry, and she actually had this, and she also had a lot of local environmental problems, and she started talking about how with coal you had more carbon dioxide being released into the atmosphere, and that started with in the Industrial Revolution, and it goes right back to the early 1800s. So there was a correlation between the initial warming that started in 1830, 1850. That was when, so Greenland, there were people living in northwest Greenland going back 1,000 years, and then they left, and then they recolonized in about 1826 when it started to warm up again. But anyway, she had this idea, and she really sold this idea of carbon dioxide being a problem, and all this money was given to different groups. And really before the 1980s, 1990s, nobody was much talking about carbon dioxide causing global warming. Now, the idea, the mechanism is that the sunlight comes in, it actually passes through the atmosphere, and much of it is absorbed by the ocean, and it will heat up the ocean, but it will also interact with the land, and you'll have this re-radiation of the thermal radiation. It's that thermal radiation that they say if there's more carbon dioxide, it's going to capture more of the thermal radiation from the re-radiated incoming solar radiation. And as that carbon dioxide absorbs as there's more carbon dioxide from the burning of fossil fuels, from the coal mining that they eventually closed down in the UK. And that energy transition had all sorts of advantages for the UK and Germany when it happened with the Kyoto Protocol, and on it goes. But what they say is that more carbon dioxide, and there's been more carbon dioxide in the atmosphere, though I'm not actually sure how much of it's from coal mining and how much of it's from the natural degassing of the ocean, because as the ocean naturally warms up, with these cycles that have nothing to do with human activity, you will get release of carbon dioxide from the oceans. So I agree there's more carbon dioxide in the atmosphere now than there was 100 years ago. But there's only so much solar radiation coming in and then being re-radiated. And the basic physics, and this is not controversial, explains that you can double your carbon dioxide again, and it's not going to have very much effect on atmospheric temperatures, because the limiting factor is not carbon dioxide, it's the thermal radiation. So you can look at it from different perspectives, but basically the IPCC and others say, for example, this year's really hot because we've got that much more carbon dioxide. In fact, we've got a bit of a spike in temperatures this year, but that spike is lagging ocean temperatures by about 2 months, because you can see that the warmth is actually coming out of the ocean. And we know that laws of thermodynamics, that heat always goes from warm to colder. And if you look at average temperatures, the ocean is warmer, and it's always warmer, and it's still warmer than the atmosphere. And that's the direction of movement from the ocean to the atmosphere. The oceans are warming the atmosphere. The atmosphere is not warming the ocean. So there was a lot of information that I conveyed there, and maybe there might be bits and pieces of it that you would like me to unpack a little bit more, because I know this isn't consensus science. And most of the time we don't have an opportunity to discuss this science because in the West, there's a huge industry pushing energy transition, and they justify that on the basis that they don't want carbon dioxide emissions from the burning of fossil fuels.
So, I mean, to sum up, actually, what you were saying, what you are saying is that carbon dioxide is something natural, not demonic, not anthropogenic, man-made, not man-made, of course, and also maybe you could touch a bit the topic that what happens if we reduce carbon dioxide? I mean, if we really start, building all those big fans that catch carbon dioxide and turn it into a stone, like they're doing this new, big thing, direct air capture of carbon dioxide. If we really manage to catch carbon dioxide from the air a significant amount, what would happen to nature?
Well, at the moment we have a lot of greening of desert arid areas because there is more carbon dioxide, and so plants don't actually need as much water to grow because carbon dioxide's often limiting, and they can close their stomata. And this actually is something that biologists know a lot about, which is the importance of carbon dioxide for plant growth. And I know in a lot of industries, for example, they have higher yields because there's more carbon dioxide. So more carbon dioxide is good for agriculture, it's good for arid regions and getting more plant growth. They say that carbon dioxide is resulting in global warming and more extreme climate. So I don't know, you said in Estonia, maybe it's not so bad that it's getting a little bit warmer. Here in Australia, we actually have a decrease in the number and intensity of cyclones. Even though they said that with more carbon dioxide we would have an increase, we actually have a decrease in the number and intensity of cyclones with the warming. So I guess you'd have to say, but anyway, if you reduce carbon dioxide levels, I don't actually think that's going to affect any of that, because I actually think that the amount being released naturally from the ocean is probably what's driving the current trend. So there's no mechanism at the moment where people could actually have an impact on atmospheric levels of carbon dioxide. Certainly I know during COVID, when people weren't traveling and on, there was no effect on atmospheric levels of carbon dioxide. And the amounts they're talking about with this carbon sequestration, it's very, very small.
You have actually argued with your own research as well that it was from 2017, I think, that it's not man-made, but the climate change is natural. So maybe again, we already talked about it, but why and how did you come to this conclusion then that man has, well, maybe nothing to do, maybe not nothing to do, but has little to do with climate change?
So if you look at the records, and I was very interested in the first instance in rainfall records, okay? And if you look at rainfall records for Australia, we have good records going back to 1850. You've probably got longer records in much of Europe. I know the records are much longer, but we have good records going back to 1850, and you can see the cycles. And then you can match the cycles to things like lunar declination, ocean overturning. So you ask, and you can see as well when they're saying the drought is never going to end and you have to install water tanks, you have to, have 2-minute showers, you have to close down, stop growing these particular crop plants because they're too water intensive. Then people like me, we look at the data and we say, well, actually, it's been drier before. It was drier 100 years ago. It was drier in the 1930s. We had dust storms and we had very dry periods in Australia as they had in the US. If you look at the US EPA data, you can see that the 1930s, they had terrible heat waves, and we had terrible heat waves and we had drought in Australia in the 1930s. We also had it, as I said, in the 1890s. And you ask, why are they saying it's so terrible now when the data very clearly shows that it's no worse than it was in the past? And then if you're me, you go, okay, well, let's see if we can forecast forward and we can forecast when this drought's going to end, and you successfully forecast that. And they're still not interested because there's so much politics associated with this nonsense story. I know that what I'm saying is not what you're hearing all the time, but I would ask you, I guess, just to think about the longer term records for where you live. How old is your village? Does it have a cathedral that was built 1,000 years? Are there records about famine periods and years of plenty? I know the Barents Sea ice edge. I think that 1866, the ice was a long way south, and then the ice moved north, and the tree line data and the tree ring data, for example, all of that shows that there's nothing exceptional about the climate at this point in time.
Yeah, yeah. Have you heard the expression that global warming or climate change is man-made? Have you heard that?
Absolutely.
Man-made. Man with double N. Man with double N.
You're talking about Professor Michael Mann.
Yes.
And his hockey stick.
Yes.
So it was really quite extraordinary the extent to which, there's all this data that's being collected, tree ring data, and some of those records, they actually go back 7,000 years for parts of Siberia, because they have these larch that grow there, and then they actually get covered in all the permafrost, and you've got these beautiful records. So you can cut these trees and you can count the width of the tree rings, and again you can see the cycles, sometimes interrupted by volcanic eruptions, which will give you cooling for a period of time. So for example, after the 1815 volcanic eruption in Indonesia, you can see in the tree ring data for Siberia that there was no summer, because there wasn't the sunlight coming through, because the sulfur was reflecting it back. I'm diverging, but basically we have beautiful records from particularly places like Russia and Finland through the tree ring data. And then you have somebody who in 1998, 1999 published these papers in Nature, where he just selected a few of the tree rings that he liked, some of the outliers, and put that with some other data that he liked to give the impression that there'd actually been cooling right up until 1850, and then suddenly there was warming. But even with the tree ring data he had, you only got warming to 1980, and then he's got what they call the divergence problem because the tree ring data starts to show cooling. So then he puts the instrumental record, so that's the mercury thermometer record, he graphs it onto that, and so they continue to have all this warming and warming and warming. So they call it the hockey stick. So you've got the stick actually shows cooling, and then the shaft shows this spike in temperatures. And so many people went, this is ridiculous, because let's have a look at all the tree ring data, for example, and it shows cycles. It doesn't show a hockey stick. Let's look at other data. Let's look at the ice core data. It doesn't show a hockey stick. It was only a few people who really spoke out against it. For example, Mark Stein called the chart fraudulent, and then Michael Mann sued him, and now after 12 years it's gone to court, and somehow or another, I don't know how, he didn't win against that DC jury. And I think that this is Mark Stein lost against Michael Mann because in the West, it's just so politically incorrect to criticize a famous climate scientist. If you listen to the podcast that was made by a friend of mine, Anne McElhenney, following that trial, you can hear all the evidence put forward to show that there are real problems with this hockey stick reconstruction, never mind that it was published in Nature and adopted by the IPCC. It doesn't, in Australia, we talk about the pub test. If it doesn't pass the pub test, as in, this doesn't make sense. If you talk to ordinary people and you show them how this was put together, it doesn't make sense. And yet it can be published in the best scientific journals, and it can convince a DC jury because they've already made their mind up and they are wedded to this idea of catastrophic climate change.
Yeah, this is an interesting court case. I hope it is, appealed. I think it was appealed by Mark Stein. And what is interesting is that the defense, the side of Mark Stein and Rand Simberg, they were presenting all kinds of, scientific data. And the other side did not, and still, as you pointed out, it's surprising the outcome, isn't it?
I was horrified because in terms of damages, the jury awarded just $1, acknowledging that Mark Stein's article based on a Rand Simberg blog actually didn't damage Michael Mann's standing. But what they did award was $1 million in punitive on the basis that Mark Stein should not, how dare Mark Stein bring into disrepute or attempt to bring into disrepute this very fashionable, famous climate scientist. Never mind that Michael Mann seems to spend most of his time on Twitter rather than actually, I would argue, doing some good climate science. And for me, and thinking about pub tests, I think it's your capacity to forecast. If you can use the hockey stick data to forecast what the climate's going to do in the future, maybe the hockey stick has some value. But I know they don't use that data. They use the data that actually shows the cycles to do the AI forecasting going forward, because that's what people really want to know. They want to know whether next summer's going to be wet or dry, whether the next winter, I assume where you live, whether it's going to be very cold or not, whether the ice edge is moving, how that's affecting, affecting so many different things. And yet these people who have become famous in climate science They've not become famous because they can actually generate good and useful climate and weather forecasts, but because they generate these nonsense historical reconstructions that are useful to those people who are wanting to force this energy transition. So going back to Margaret Thatcher, she absolutely could see advantage for the UK with the Kyoto Protocol. They would get all these concessions as they transitioned from coal to gas, and she was very keen on nuclear. And I know in Australia at the moment, there's all this discussion between nuclear versus renewables, when the reality is we should not be closing down our coal-fired power stations because they are reliable, they provide cheap energy, and they make our industries competitive. And yet, you know, the way the politics is, there are an elite who can't make money out of the coal-fired power stations. They want, and it's all government subsidized, there is all this investment in renewables, and there are particular people who have invested in that technology, and they're making so much money, all underpinned by government. But the ordinary person's electricity price is going up.
So it might be fair to say that we don't have a climate crisis as such, but we have a crisis, a political crisis, which is, you know, somewhat combined to certain business circles, and this is the real crisis we are facing here.
And we are on the edge of an energy crisis here in Australia. We are losing particular industries because energy is becoming too expensive and too unreliable. And so life is becoming more expensive for ordinary people because energy and cheap energy underpins so much of our wealth here in Australia. And there's this huge push to windmills where I live, and solar where I live. And, you know, they're cutting the sides of the hillsides to put in windmills. They're bringing in the turbines from overseas. They're making the ports bigger. They're transporting these windmills to these rainforest areas. It's not a practical way of producing energy, but I think you know, it's coming from places like Denmark. People over there, they're making huge amounts of money. All of this being bought by our superannuation funds, underpinned by government, and the coal royalties are paying for that. So the money that we normally make, the surplus that we have from selling coal, is being, I think, wasted on these renewables that are unproven, expensive, and then they've got to destroy more rainforests to put these transmission lines through. So we really are on the verge of an energy crisis in terms of reliability and expense, and it's all being justified on the basis that we have a climate crisis. And yet you look at things, and maybe I can talk a little bit about the Great Barrier Reef, because you look at something like the Great Barrier Reef, you look at how sea levels have changed, you look at the instrumental temperature record, and you can see that there are just cycles. There's no crisis at all.
Yeah, Great Barrier Reef. Sorry. You have also worked with Great Barrier Reef extensively, and you also have a personal connection, as I understand, because you have been snorkeling and diving there for decades already. So yeah, it's a symbol of climate change or global warming or whatever you call it. But what's the health of the Great Barrier Reef? I mean, is it really dying, as they say?
So the official statistics, so that's the Great Barrier Reef Marine Park Authorities and the Australian Institute of Marine Science statistics, actually show record amounts of coral cover for 2 of the 3 major regions, and increasing coral cover. Now, I've got problems in terms of how they put that data together, because they mostly survey around the perimeter of the reef, which ignores the reef crest where there's actually most of the coral, and those reef crest areas have been more affected over recent years by the bleaching. But if you look at the official data, it shows record cover or almost record coral cover. And that's actually because we've had such a reduction in the number and intensity of cyclones since the satellite record began, since the 1970s. And I can send you that data if you want to include it in this podcast. It's quite dramatic, the reduction in the number and intensity of cyclones. Now, at the beginning of every cyclone season here in Queensland, in the northeast of Australia where I live, the Bureau says how this cyclone season, we're going to have more cyclones, they're going to be more intense. And it's never the case. And you look at the data, I love data, I'm always downloading data, you see a reduction in the number and intensity. That means that there's more coral, because cyclones, they actually devastate coral reefs. Now, I've been snorkeling and diving the reef since I was 7 years old, and I've just turned 60 years old. So that's a lot of time to be out looking at individual reefs. And what I can see is, and I guess it's the last 5 years now, every time I hear that there's bleaching somewhere, I actually go, and now with an underwater photographer, and I film, and I try and get the information out, because so often people would say to me, oh, you've been to the wrong reef. And now I always say, okay, where's the bleaching? Let me go, let me record it. Now, 2022, it was making headlines around the world. John Brewer Reef was meant to be epicenter of the 6th mass coral bleaching. Straight away, I said to Stuart in Cairns, and he's north of Townsville. I was living south of Townsville. I said, well, go to Townsville. It's easy to get out to John Brewer Reef. We know the operator that takes the charter out there 3 times a week. We're going to get there. We're going to film it. And I needed to get some money from Institute of Public Affairs, a think tank that has been funding that work. And they said, Jen, it's all over the papers. It's all over the radio. That reef has been like really badly bleached. Do you really want to take this ace photographer out there and film it all? And I said, absolutely. We will film this reef at its worst, and we'll watch the recovery. I got there. There was a little bit of bleaching, but mostly I'd never seen that reef look so beautiful. The corals were a bit stressed, so they'd kicked out some of their zooxanthellae, so a lot of the natural fluorescing protein was showing through. So the reef was much pinker than usual, because a lot of the colour at healthy reefs is often masked by the algae. So we had this beautiful, beautiful reef, and we filmed it all, and I've made a little film that you can watch, Bleached Colourful. If you go to YouTube, you can put my name, Marohasy, and Bleached Colourful, and you'll find it, or go to my website, jennifermarohasy.com. And you'll see what that reef looked like when it was being reported around the world as the epicenter of a 6th mass coral bleaching. It wasn't badly bleached at all. It was hardly bleached at all. It was a little bit stressed. But you know what? Just at the end of February, that reef, John Brewer Reef, was actually hit. It was hit by a cyclone Kurile. Even though we've got a reduction in the number and intensity of cyclones hitting the east coast of Australia, when you're, this reef, the cyclone went right over the top of it. It actually sat over the top of it for a period of time, and it's just devastated the reef. It's knocked a hole where they were talking, where the bleaching was. And by the way, the corals came back from that bleaching within 3 months. That whole wall of coral has actually collapsed from the cyclone. The reef crest has been scoured with the cyclone going over the top. That reef right now looks shocking, but I can't actually get people to come out and look at it and see what cyclone damage does. I mean, it's just mad here in the West. The media report this reef being in trouble when there was hardly any bleaching at all. They didn't report its recovery from the bleaching, which happened within 3 months. And now 2 years later, that same reef has been absolutely smashed by a cyclone and nobody wants to talk about it.
So maybe they just, don't care, and for the sake of, I don't know, propagating some kind of crisis, they just want to get your attention at certain points of time and not at other points of time. So again, this is...
So early 2022, they had all this UNICEF, United Nations Environment Program, people coming out. They were really quite determined to make reef health a federal election issue. And now they've got the government that they want, and also I think they don't want to link cyclone damage to reef health, because then they'd have to talk about the fact that the number and intensity of cyclones is decreasing. So there's just this narrative that the mainstream media just repeat, and it has no relationship to what's actually happening at places like the Great Barrier Reef. When I first started, so it was 2019, there was a big court case that was relating to a scientist losing his position at a university because he had said that this particular reef actually still exists and wasn't at all affected by sedimentation or ocean acidification. And so I actually went and filmed that reef, and then I was told, oh, but you should have gone to another reef because that's where the worst bleaching was. So then I went to that other reef, and they said, oh, you're too late because, the bleaching was back in 2016. You should go. And I just kept on going to where they told me to go. And everywhere I was finding beautiful, beautiful corals, beautiful, beautiful reef. And I've documented much of this in some of the documentaries I have made recently. But it's just in the last, just in February, that this, my all-time favorite reef, which is very accessible, has been, as I said, hit by this cyclone, and it's looking terrible, but nobody seems to want to care about it.
So, Jennifer, let me ask you this as well, although I kind of know the answer already. How much open discussion on these issues do we have in our societies? What is your feeling? How much is censored? Can we discuss freely such things? And even in the academia, how much academic freedom we have? Among climate scientists, or in climate science.
Oh, very, very little now. So if you go back not so many years, when I was with the sugar industry, and when I was talking, so we're talking about 2003. So I guess we are talking 20 years ago. And then I was with the Institute of Public Affairs the first time around. I was often on television. They'd have me on as the sort of alternative voice saying, oh no, the drought's going to end and this is why I think the drought's going to end, or well, we've had flooding because of these reasons and those reasons. But that's really all changed now. And even back in 2012, I was having difficulty getting my rainfall forecasting papers published, but I could still really get them published through to 2017, when I published a paper on temperature records in a very good journal, GRSJ, and that paper created quite a stir, and there was a whole Twitter campaign against me and against that paper, and I just lost I'm blacklisted now. If I turn up at, or I'm invited to speak at particular events, or have been invited to speak at particular events, the event organisers now say the Australian Broadcasting Corporation won't cover this event because you're going to be there. So can you please not be on that panel anymore, because we want the mainstream media to cover it as they always have. So I'm listed, even though now I have more publications than I had 20 years ago in the climate science area, and more credibility in terms of my consultancies with the Indonesian Bureau of Meteorology, and on it goes, books that I've edited, and on it goes. The mainstream media will not tolerate my viewpoint. And even now within skeptical circles, because I talk about how we have to contest the instrumental temperature record, and we have to explain that there was cooling through the first part of the 20th century before there was warming in the Northern Hemisphere after 1975. People say to me, oh, that is so like unpopular to say that, and it sounds so conspiratorial that we honestly don't want you on the panel talking about that. We'd rather just not talk about the fact that they've homogenized and changed the record because we don't want to sound too extreme. So there's all this posturing rather than letting knowledgeable people discuss rainfall and temperature records, which underpin fundamentally everything. So it's not that people prove me wrong. It's not that any of my papers have been have not stood the test of time. In fact, my method of forecasting that goes back it goes back a dozen years now, is now being accepted as a better method of rainfall forecasting. So I was a decade ahead of my time, but people do not want to interview me because they don't like the truth that I speak, and it is so jarring relative to what they are being told.
Yeah, it is really disturbing to hear how it has all changed in journalism, in mainstream media. And, there is no science in settled science, so to say. So I think you are correct there that if something is to be said on your work, then it should be a discussion, and it should be an open debate, not just, dismissing your work and parroting all the things that get funding from the sponsors.
Yeah, so what they really just try and do is completely ignore. They try and completely ignore my work and the papers that I've published. And I'm very grateful to the Institute of Public Affairs, who keeps supporting me and my work. And we'll be putting out another Climate Change, The Facts. We've been publishing this series with some great climate scientists, because there's actually still a lot of really good climate scientists at universities or recently retired from universities who want to talk about, for example, how the tree line changes, how the coral growth rates change, how the Barents Sea ice line, and also want to talk about, we had a whole book looking at different ways that you measure temperatures and looking at the long historical records for single locations and how they show the cycles. So there's still a niche market for some of my work and editing of people who need to be heard. Our next book is going to include John Clauser talking about the importance of clouds, and so he's contributing a chapter to the next book. And he, of course, was a Nobel laureate in physics just 2 years ago. So there's still people speaking out, and there's still people. There's still a few of us, I guess, carrying the torch, and I guess it's lovely to be able to talk to you on this podcast. And I'm sorry that I've diverged a bit and got a little bit technical, but it's lovely to be able to talk about these things and about some of the things that affect natural climate cycles, whether they're daily, seasonal, 60-year cycles or 1,000-year cycles.
Yeah, it has been really lovely to talk to you as well, Jennifer. And sadly, our time is up for today. I think there was a lot of new info for me and a lot of new info for our audience here, and there is a lot to digest here. So thank you again, Jennifer, for taking the time.
Well, I encourage you to have some other skeptics on your program, and maybe a few of us discussing some of the different issues perhaps down the track, because climate science and climate change and historical temperature reconstructions are fascinating, and I think they're interesting to ordinary people.
Thank you. So this was the Freedom Research podcast, and my name is Hannes Sarv. So in the meantime, you should go and check out our new stories at freedomresearch.org, and we're going to be here again soon with new guests and talk about important topics in the future as well. See you soon.